Now we're going to practice using rule number 3 and 4 along with 1, 2, and 5. So now we're going to look at rule number 3 and number 4. Here we have the integral of x plus 2 dx. This is the same thing as the integral of x dx, because I can multiply this differential to each term in the parentheses. So the integral of x dx plus the integral of 2 dx. These are indefinite integrals. I know that you're probably thinking, I don't know what the difference between an integral and an indefinite integral is. I just want to keep saying indefinite integrals so that when we get to definite integrals, you'll have an aha moment. You'll say, aha. So we have the indefinite integral of x dx. Well, that value is x squared over 2. Hopefully you're going to get faster at that. And then we're going to add to that the integral of 2 dx. Well, that's a constant. And the integral of 2 dx is 2x. And then, of course, we have plus a constant at the end. Now, you might have been wondering, why didn't I put plus a constant with the blue function and plus a constant with the red function? Well, I add them all at the end because if I had plus c for the blue and plus another c, we'll call that c2 and maybe c1, I would just end up adding the constants together and maybe get a c3. Well, we don't use subscripts. We just put all the constants together and call it c. So no need to be taking the indefinite integral and finding the separate constant of each term. We just add the constants together at the end and call it a day, plus c at the end. Okay, let's try the next one. The indefinite integral of 3x to the 4th minus 5x squared plus x dx. That's 3x to the 4th dx minus 5 times the integral of x squared dx plus the integral of x dx. And this first one is going to be 3x to the 5th over 5. You're going to start loving this. Minus 5x cubed over 3 plus x squared over 2. And then at the end, we always add our constant, which gives us our final answer of 3x to the 5th over 5 minus 5x cubed over 3 plus x squared over 2 plus c. Okay, time for you to try, and then I'm just going to give you the answer. So please make sure you press play or press pause, and then only press play when you're ready to see the answer. Okay, the answer is x to the 4th power minus 5 over 2x squared. Now I'm writing that a little bit different, or even saying it a little bit different, because you can, plus 2x plus c at the end. Don't forget the c. Hopefully I've said that enough that you won't forget that c, because it is critical. Okay, our last two problems that we're going to do an example, a try, and then you're going to get to practice this before we expand on finding the integrals in the second half of this section of the textbook. So let's finish up right here. The integral of x plus 1 over the square root of x dx. Now you might already have an idea of what it is that you need to do. It would be really nice if we could just separate out, like I did on example number 5. It was nice how we split up using rule number 3 and rule number 4 with adding and subtracting. But here I have one term that's connected by division, right? And I have a monomial in that denominator. I paused there for a minute like I didn't know what a denominator was. I'm going to rewrite this x over the square root of x. And I want to do this in a very specific way, plus 1 over the square root of x dx. Notice how I put that in parentheses. I really wanted to do that in a specific way by using those parentheses to show you that this is one term, so one term times dx. Once I expand it out into two terms, I have to put the parentheses there because the differential goes with each term in the parentheses. So now I'm going to separate this out. X over x to the 1/2 is just x to the 1/2 dx plus x to the negative 1/2 dx. And now the indefinite integral of x to the 1/2 dx is going to be x to the 3/2, and then dividing by 3/2 is the same as multiplying by 2/3, plus, we'll add 1, x to the 1/2, and dividing by 1/2 is the same thing as multiplying by 2, and then we add c. Now sometimes the textbook publisher will allow you to just to keep your exponents in rational form, and other times they'll want you to put it back into radical form. But this is really good. I believe that you know how to put this back into radical form if you needed to. So make sure you're checking your answers so that you get a feel for how the problem is supposed to be worked out. So let's try this next problem. I'm going to work it out, but I want you to press pause so that you don't see what I'm doing. But I am going to work this one out so that you can see all of my work. Okay, so the work that I have is x to the first over x to the 1/2 dx plus, and I have the indefinite integral of 2 over x to the 1/2 dx. And then I might even write that differently, x to the 1/2 dx, because that's how it simplifies. And then I'd have 2x to the negative 1/2 dx. And now I'm ready to find the integral, the indefinite integral. Let's start with the first one. We're going to add 1. So x to the 1/2 plus 1, that's 3/2, divided by that 3/2, and then plus, and here we'll have 2, that 2 came to the front, right? And then I've got x to the negative 1/2 plus 1, well that's just 1/2, divided by 1/2. And then my final answer, that's going to be x to the 3/2 in the numerator. Dividing by 3/2 is the same thing as multiplying by 2/3. So 2/3 x to the 3/2 plus dividing by 1/2 is the same thing as multiplying by 2. So that's going to be 4 x to the 1/2, and then plus c. Don't forget c. Why not? Because it's critical.